G'day YouTube, warbles on a lot here. About to analyse a pressed sheet metal fan. When I took this little unit out of the box, I was initially kind of disappointed with the idea of the sheet metal fan. And although it did indisputably function and generate a flow of air past the cooling fins and out into the room, perhaps because I sort of fancy myself as a propeller carver working in wood, this didn't strike me as being particularly elegant, not at first glance. However, when I found somewhere to stow this thing when not in use, I picked a spot where I can see it while I sit in bed late at night with the light on. And regarding the fan, from such a perspective as to be able to fully appreciate the fact that there was something kind of special about the geometry. If you have a look, you can see that those rectangular stiffening ribs, they don't line up with each other across the axis. If you look kind of carefully, you'll see that the straight leading edges are actually swept back. You can see that the line where the flat leading edge curves into the pitched trailing edge, they've got two parallel lines of them crossed at 90 degrees, but they're not running at 90 degrees to the airflow. They're decidedly swept back at like 45 degrees. And by golly, by Jove, by jingo, the amount of curvature where it turns from a flat plate leading edge to a deflected trailing edge is 17 degrees. And if you look carefully, you'll see that the turbulence from the stiffening rib is out of the way by the time the airflow strikes the camber change line on the cord. Anyway, I decided the only way to really get my head around this would be to take the fan off and draw some carefully selected concentric circles onto a piece of paper and then overlay the two. So we apply the Allen key, remove the fan, place it on the aforementioned sheet of paper, apply dividers, use the dividers to scratch the circles onto the paper, because guess who can't find one's lead pencil compass somewhere in amongst the clutter. And then ink in the scratchy paper and see what we can see. Isn't that fascinating? This thing has been very, very, very carefully thought out by whoever it was who figured it out for absolute maximum efficiency. You can't get air to change direction any more than 17 degrees, and 17 degrees, as measured with a protractor, is how much of a change in direction the airflow is being asked to make when it gets scooped up by the almost flat leading edge. There's about 1/4 of a degree angle of attack on the whole of the leading edge. Then it gets back, well, 2/3 away along the camber, and then you've got this semicircular, elliptical little kick flick to the trailing edge. As I noted earlier on in the video, a swept leading edge leads to lower drag. Look at the angle between the leading edge of the blade and the airflow. An elliptical sweep all the way out to the tip. That's the direction of the curve line across the blade, but that you don't get, all the way out. That's a swept impingement line. This is just brilliant. The whole center section here is acting as a streamlined strut. This is absolute minimum drag territory for the leading edge of the strut. This is what's actually doing the work. And that is your circumference line. So they contrive to even get the strut working by staggering whereabouts on the cord the camber kicks in, camber being French for curvature. And yeah, as I pointed out, these stiffening ribs don't actually line up with themselves. And 3/4 of the blade area is in advance of the long axis of the blade. Somebody spent an enormous amount of time on their airflow computer modeling this for optimal efficiency at generating just a little bit of airflow on almost no power. And as good a woodcarver as I like to think that I am, I don't know that I could make anything that's going to be as technically efficient as this is. In maximum engagement with that little air column at maybe 300 revolutions per minute, perhaps as high as 400. And I've seen it generate 1 to 1.5 miles per hour, call it 2 kilometers per hour. On the tiny little bit of current emerging from this Peltier device, which is sandwiched between an aluminium I-beam heat conductor and a really complicated aluminium tube extrusion heat sink. And I just want you to pay attention to the fact that this thing has got 4.5 corrugations pressed into its fins on all the surfaces except the one that's exposed to the hot air coming up off the stove plate. Like, this thing has been optimized to the max. And there you can see its little electric engine right in the center of perhaps the coolest airflow of all. And of course it draws air through the cooling fins with the action of the fan. So there you go, and now you know, if you have a stove with a flat top and you see one of these for sale, I can't speak for the other brands, but despite the Chinglish on the box, I reckon these things are absolutely great. Sort of gives you the idea of it. Yeah. low drag, high efficiency, low output, low power, one piece sheet metal pressed air screw. I like it. Warbles on a lot to YouTube. Ciao.